Jai Shri Gurudev. Good morning to everyone, students. Welcome to chemistry class. In the previous class, we have studied the named reaction called as condensation reaction. Now we are going to study the second chemical reaction called Cannizaros reaction. This Cannizaros reaction is also very important for your exam purpose. Now it is defined as, or the meaning of Cannizaros reaction is the aldehydes which do not containing alpha hydrogen. Observe here, to carry Cannizaros reaction, the aldehydes which do not containing alpha hydrogens, those are treated with a strong base such as sodium hydroxide or potassium hydroxide. We get primary alcohol and sodium or potassium salts of carboxylic acids is called Cannizaros reaction. Okay, in the previous reaction it means in aldol condensation we are treating aldehydes or ketones which containing alpha hydrogens with dilute base. But in the Cannizaros reaction, aldehydes which do not containing alpha hydrogens are treating with strong base like NaOH or KOH. We get primary alcohols and sodium or potassium salts of carboxylic acids. It's called Cannizaros reactions. Now observe the chemical reaction. Aldehydes, let's take simple aldehyde which do not having alpha hydrogen, that is called formaldehyde. Formaldehyde. Here we are taking one molecule of formaldehyde which is reacts with one more molecule of formaldehyde, C double bond OH, that is HC double bond OH, two molecules of formaldehyde which is treating with a strong base, that is concentrated NaOH, or you can also write NaOH. Don't need to write dilute or concentrated, or you write, if you confuse, strong sodium hydroxide NaOH, or you can also write like that, base OH minus. They given OH minus also. It means either sodium or potassium base. Now observe, one molecule is converted into carboxylic acid and one is converted into alcohol. Here both are same, therefore one is converted into alcohol and one is converted into carboxylic acid. Observe, this H is get added to this carbon. ಈ ಹೈಡ್ರೋಜನ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಈ ಕಾರ್ಬನ್ ಗೆ ಅಟ್ಯಾಚ್ ಆಯಿತು. ನೋಡಿ ಅವಾಗ ಏನಾಯಿತು, CH2 ಇರೋದೇನಾಯಿತು, ಒಂದು ಹೈಡ್ರೋಜನ್ ಹೋಯಿತು ಅಂದ್ರೆ CH3, that is CH3 bond O, ಆಕ್ಸಿಜನ್ ಆಯಿತು. ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್ ಏನಾಗುತ್ತೆ ಅದ್ರ ಜೊತೆಗೆ ಆಡ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ OH ಅಂತ ಇದೆಯಲ್ವಾ, OH ಅಂತ ಇರೋದ್ರಲ್ಲಿ H ಬಂದ್ಬಿಟ್ಟು ಈ ಆಕ್ಸಿಜನ್ ಜೊತೆಗೆ ಆಡ್ ಆಯಿತು OH. ಸರಿ ಆಯ್ತಲ್ವಾ. ನಾವು ಒಂದು ಹೈಡ್ರೋಜನ್ ಇಲ್ಲಿ ಲಾಸ್ಟ್ ಆಗಿದೆ, ನೋಡ್ಕೊಂಡಿರೋದೇನು CHO, that is HC double bond O, HC double bond O. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲೊಂದು ಆಕ್ಸಿಜನ್ ಇದೆಯಲ್ಲ, this oxygen and sodium or potassium. ಇಲ್ಲಿ ಸೋಡಿಯಂ ತಗೊಂಡಿದ್ರೆ ಸೋಡಿಯಂ ಸಾಲ್ಟ್ಸ್ ಬರುತ್ತೆ, ಪೊಟ್ಯಾಷಿಯಂ ತಗೊಂಡಿದ್ರೆ ಪೊಟ್ಯಾಷಿಯಂ ಸಾಲ್ಟ್ಸ್ ಬರುತ್ತೆ, that is ONA. So this is called alcohol, primary alcohol methanol, and this is carboxylic acid, that is sodium, this is formate, sodium formate, formic acid, that we call sodium formate. Now observe, our sodium salts of formic acid, we can also write sodium salts of formic acid. Now observe here, this is the Cannizaros reaction. This reaction we will understand only when we are knowing the mechanism. But there is no in your syllabus the mechanism, but never asked in the exam also. So see how it is happen. Just to understand chemical reaction I am telling here, simply understand, this is the formaldehyde, C double bond O, bond H. Base is nothing but what? OH minus. When we are adding base, sodium and potassium salts. And let's take the sodium salt NaOH, Na plus OH minus. This is the base ionization, right? Now one molecule we are taking here, H. This OH minus get attached to this carbon because there is no acidic proton to abstract. ಇಲ್ಲಿ acidic proton ಅನ್ನೋದು ಇಲ್ಲಿ abstract ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಅದಕ್ಕೆ ಏನಾಯ್ತು ಬೇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಬಂದು ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಎಲೆಕ್ಟ್ರೋಫಿಲಿಕ್ ಸೆಂಟರ್ ಇದೆ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಲೆಕ್ಟ್ರೋಫಿಲಿಕ್ ಸೆಂಟರ್ ಬಂದು ಅಟ್ಯಾಚ್ ಆಯಿತು. ಅಟ್ಯಾಚ್ ಆದಾಗ ಏನಾಯ್ತು ಇದು O ಮೈನಸ್ ಆಯಿತು. ವಾಟ್ ಯು ಗೆಟ್ H ಬಾಂಡ್ C ಬಾಂಡ್ H ಬಾಂಡ್ OH ಬಾಂಡ್ O ಮೈನಸ್ ಈ ತರ ಆಯ್ತಲ್ವಾ. So O minus ಆಯಿತು. Now this bonded electrons moves towards this side and this H is eliminated. So what you get H C double bond O here C double bond O bond OH minus H ಅನ್ನೋದು ಎಲಿಮಿನೇಟ್ ಆಯಿತು minus H plus sorry not plus H minus H ಮತ್ತೆ bonded electron ಆಯಿತು H minus ಆಗಿ ಎಲಿಮಿನೇಟ್ ಆಯಿತು. again protonium ion ಬಂತು. so ಅಂದ್ರೆ H minus ion hydronium ion you get them. Now one more molecule is reaction, another is there, right? Means second molecule is dying. Here only one molecule is react, the second one more molecule will be react. Now here there is solution, one more molecule, that is HC double bond O bond H. Now this H minus get attached to this carbon, this O will be move on oxygen, means the bonded electrons move on oxygen. What you get, see HC HC H, this H is get added, this bond H, now bond O minus. Okay, these two are present in the solution, right? Very solution alle irutte. Enaguttade, now these two hydrogens will exchange. ಇಲ್ಲಿರುವಂತ ಹೈಡ್ರೋಜನ್ ಇಲ್ಲಿ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿರುವಂತ ಹೈಡ್ರೋಜನ್ ಏನಾಯ್ತಂದ್ರೆ ಇಲ್ಲಿ ಬಂದು ಕೂತ್ಕೊಂಡ್ಬಿಡುತ್ತೆ. ಕೂತ್ಕೊಂಡು CH3OH ಆಯಿತು. CH3OH, you get CH3OH, right? then ಈ O ಮೈನಸ್ ಅಂತ ಉಳ್ಕೊಳ್ಳುತ್ತಲ್ಲ, ಇಲ್ಲಿ ಮೈನಸ್ ಚಾರ್ಜ್ ಅಲ್ಲಿ ಮೂವ್ ಆಯಿತು. ಬೇಸ್ ಅಲ್ಲಿ ಏನಿದೆ Na ಪ್ಲಸ್ ಹಂಗೆ ಉಳ್ಕೊಂಡಿದೆ, ಆ Na ಪ್ಲಸ್ ಬಂದು ಇಲ್ಲಿ ಕೂತ್ಕೊಳ್ಳುತ್ತೆ. okay, you get two products. that is only here I am writing. okay, this is the mechanism. Don't get confused if you not understand, even though just understanding chemical reactions of Cannizaros reaction, how we are writing the reaction. Now similarly observe, if you are writing one more example here, just in place of hydrogen write benzene. This is example 1. now example 2. if you are writing benzene bond C double bond O bond H, observe this benzene do not contain alpha hydrogen. already I told you in the last video, here there is no alpha hydrogen, so that it undergo only Cannizaros reaction, not aldol condensation. ಕೇಳ್ತಾರೆ exam ಅಲ್ಲಿ, why benzene is not undergo aldol condensation? because there is no alpha hydrogen or acidic hydrogen, so that it doesn't undergo aldol condensation. ಇಲ್ಲ ಅಂದ್ರೆ ಏನು ಕೇಳ್ತಾರೆ ಅಂದ್ರೆ, why the benzene undergo Cannizaros reaction? because the aldehyde means benzene do not containing alpha hydrogen, so that it involve or undergo Cannizaros reaction. For both the answer is same, but the way of writing is different. okay, anyhow you have to be understand the concept behind the aldol and Cannizaros named reactions. okay, now here one molecule of benzene we are taking, and the second one C double bond O bond H. what its name? benzene. now observe, one CHO becomes part CH3. ಏನಾಗಿದೆ C double bond H, sorry C two hydrogens and oxygen. ಅಂದ್ರೆ C double bond O ಎರಡು ಹೈಡ್ರೋಜನ್ ಇರೋದು ಏನಾಯ್ತು CH3OH ಆಯ್ತು, O ಅನ್ನೋದು OH ಆಯ್ತು, CH2 ಅನ್ನೋದು CH3 ಆಯ್ತು. ಅದೇ ರೀತಿ ಇಲ್ಲಿರುವಂತ ಕಾರ್ಬನ್ ಏನಾಗುತ್ತೆ CH2 ಆಗಬೇಕು. ಈ ಹೈಡ್ರೋಜನ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಬೆನ್ಸಿನ್ ಇದೆ, ಈ ಹೈಡ್ರೋಜನ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇದೆ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಸೊ ರೈಟ್ ನೌ which is treating with a strong base, concentrated base NaOH. okay, so ಏನಾಯ್ತು ಅವಾಗ benzene ring ಸಿ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ಬಾಂಡ್. ಸಿ ಓ ಅನ್ನೋದು ಏನಾಯ್ತು, ಸಿ ಓ ಅನ್ನೋದು ಓ ಎಚ್ ಆಯ್ತು. ಓ ಸಿ ಹೈಡ್ರೋಜನ್, ಅದ್ರ ಜೊತೆಗೆ ಇನ್ನ ಒಂದು ಹೈಡ್ರೋಜನ್ ಸೇರ್ಕೊಳ್ಳುತ್ತೆ, ಹೆಚ್. ಹೈಡ್ರೋಜನ್ ಎಲ್ಲಿಂದ ಬಂತು, ಇಲ್ಲಿಂದ ಬಂತು. ಸೊ ಇಲ್ಲಿಗೆ ಯಾವ ತರ ಬಂತು ಅಂದ್ರೆ ಓ ಎಚ್ ಬಂದು ಇಲ್ಲಿ ಸೇರ್ಕೊಂತು. ನೆಕ್ಸ್ಟ್ ಪ್ರೋಟಾನ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಯ್ತು, ಪ್ಲಸ್ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ದಿಸ್ ಒನ್. ದೆನ್ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ ಎಚ್ ಇರೋದು ಏನಾಯ್ತು, ಸೆಕೆಂಡ್ ಕೇಸ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಹಂಗೆ ಇದೆ, ಈ ಹೈಡ್ರೋಜನ್ ಅದೇ ಬೆನ್ಸಿನ್ ಅನ್ನ ಹಂಗೆ ಬರ್ಕೊಂಡಿದ್ದೀವಿ, ಬಾಂಡ್. ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ ಸೇಮ್ ಹ್ಯಾಸ್ ಇದೆ, ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ ಬಾಂಡ್. ಎಚ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಏನಾಯ್ತು, ಓ ಎಚ್ ಅಥವಾ ಓ ಎನ್ ಎ ಬಂತು, ಓ ಎನ್ ಎ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಸೊ ನಿಮ್ಗೆ ಸಿಂಪಲ್ ಆಗಿ ಅರ್ಥ ಆಗ್ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಎನ್ ಎ ಓ ಎಚ್ ಅಲ್ಲಿ ಇರುವಂತದ್ದು ಎನ್ ಎ ಓ ಎಚ್, ಎನ್ ಎ ಓ ಅಂಡ್ ಹೆಚ್. ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಈ ಎಚ್ ಅನ್ನ ಈ ಎಚ್ ಎರಡು ಎಚ್ ಗಳನ್ನ ತಗೊಂಡ್ಬಂದು ಇದಕ್ಕೆ ಸೇರಿಸಬೇಕು. ಓ ಎನ್ ಎ ಇರೋದನ್ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಬೆನ್ಸಿನ್ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ ಎನ್ ಎ ಬಂದು ಇಲ್ಲಿ ಕೂತ್ಕೊಳ್ತು, ಯು ಗೆಟ್ ದಿಸ್ ಒನ್. ದೆನ್ ಆಲ್ರೆಡಿ ದೇರ್ ಇಸ್ ಒನ್ ಹೈಡ್ರೋಜನ್. ಓಕೆ, ಈ ಹೈಡ್ರೋಜನ್ ಇಲ್ಲೇ ಇದೆ, ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಬಂದಿರುವಂತಹ ಹೈಡ್ರೋಜನ್ ಇಲ್ಲಿ ಸೇರ್ಕೊಳ್ತು. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಸಿ ಹೆಚ್ ಓ ಎಚ್ ಸ್ಟ್ರಕ್ಚರ್ ಬಂತು. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಬೆನ್ಸೈಲ್ ಆಲ್ಕೋಹಾಲ್, benzyl alcohol, and this is called sodium benzoate. Benzoate. If you are taking sodium, you get sodium salt. If you are taking potassium, you get potassium salt. Here also same, the ONA is added here. You get C double bond ONA. Then this hydrogen and one of the hydrogen from here, you get CH3OH. Okay, so this is the Cannizaros reaction. Now cross Cannizaros reaction or mixed Cannizaros reaction we are going to study. Now the second one is cross Cannizaros reaction under Cannizaros reaction only. So in this cross Cannizaros reaction, similarly same like cross aldol condensation, we are taking two different aldehydes, those do not having alpha hydrogens. Okay, now one is formaldehyde and the second one is benzaldehyde. These do not having, means these two do not having alpha hydrogen or acidic hydrogen, so that they undergo Cannizaros reaction. However, they not undergo aldol condensation. Okay, now take two different aldehydes. One is formaldehyde, one is benzaldehyde. This is benzaldehyde. The second one is formaldehyde. HC double bond O bond H, which is treating with strong base, that is concentrated base NaOH or KOH. Now what will happen? See, you get one is alcoholic group and one is ketonic group, one is acid group, one is alcoholic group, one is acid group. In this case, this will undergo aldol. Sorry, this will undergo alcohol, means it will give alcohol, it will give carboxylic acid. You get benzyl alcohol, benzene ring bond. This CHO becomes alcohol, undergo reduction, CH2OH plus addition of hydrogen. This is reduction one, this is oxidation one. Now C double bond OH becomes COONA, C double bond ONA. Get this one. So benzyl alcohol, remember, very important, benzyl alcohol, and this is sodium formate, sodium salts of formic acid or sodium formate. You get this one. So observe, why you get these products only, why not you get this one? See, benzene, C double bond ONA. This is becomes acid now, and the other one is alcohol. Why not we get these two? Why we get only these two only? Because due to the presence of electron withdrawing group, benzene. This is the benzene ring, electron withdrawing group. Sorry, not withdrawing group. This is electron donating group. It donates electrons towards the carbon side. electron donating group irutte towards carbonyl group side donate ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಇಲ್ಲ ಅಂದ್ರೆ one more reason is here there is resonance like that. This is undergo resonance with this carbonyl group so that it ready to undergo reduction. But in such concept is not observed in formaldehyde because absence of electron donating group. Therefore it is readily undergo oxidation, you get salts. Okay, so that you get these two products, these two are not. Okay, this is the reason very important. Cross Cannizaros reaction ಅನ್ನೋದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಎಕ್ಸಾಮ್ ಗಳಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಮೈನ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ. ಅದೇ ರೀತಿ ನಿಮ್ಮ CET ಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. CET ನೀಟ್ ಜೆ ಗೆ ಡೆಫಿನೆಟ್ ಆಗಿ ಕಾಮನ್ ಆಗಿ ಕ್ರಾಸ್ Cannizaros ರಿಯಾಕ್ಷನ್ ಇದೇ ಕ್ವೆಶ್ಚನ್ ಇರುತ್ತೆ. ಓಕೆ, ಪ್ರಿಂಟ್ ದಿ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಂತ ಕೊಟ್ಬಿಟ್ಟು ಕ್ವೆಶ್ಚನ್ ಮಾರ್ಕ್ಸ್ ಕೊಟ್ಬಿಟ್ಟು they given 4 options. Choose the right one, like that they asking. You have to choose these two. There is benzyl alcohol and sodium carbonate. Okay, now take the second one, means the next chemical property is electrophilic substitution reactions. The next concept is electrophilic substitution reactions. So, in electrophilic substitution reactions of aldehydes and ketones, presence of electron withdrawing groups like aldehydes and CHO, that is aldehyde functional group, and ketone functional group CO, the electrons is deficient at meta subposition. Therefore, the newly coming electrophile should be attached at ortho and para position. You get two products. Now example C students, in electrophilic substitution reaction, let's take the example benzoyl. That is C double bond O bond H bond H. This is benzoyl, means aldehyde. We are going to study the electrophilic substitution reactions of aldehydes and ketones. Now we are taking aldehyde. This is called benzoyl. Now in this case, these pi electrons of benzene undergo resonance with this oxygen means carbon, you get one more structure. See, when these electrons move towards carbon side and these electrons are oxygen, you get structure of the kind like that. These two are not disturbing, right as it is. Then C bond O minus bond H, and here this bonded electrons moves towards carbon side, carries positive charge. Now the second one, these two moves towards the positive charge side, you get like that, bond O minus H double bond. Okay, I hope you know well how to write resonance structures. We have already studied in phenols and the aldehydes in the beginning. Okay, and also in ketones, so that I am writing here fast. See, double bond, then bond, here carries positive charge, then again double bond. And one more structure is resonance structures. One more is, then again it moves towards side, positive charge side, and carries positive charge here. Double bond, C bond O minus bond H, then here bond, double bond, positive charge. Okay. See, observe, in these three cases, the positive charge is formed at the ortho and para position. Positive charge is formed at ortho and para position. The positive charge is formed, it means electrons are deficient, and already we are saying electrophilic substitution reaction. Electrophile is nothing but electron deficient species. So that both are positive charge, hence the electrophilic substitution reaction do not happen at ortho and para positions. Okay. However, it is very favors to undergo at meta position because there is no deficient or rich at meta position. However, the electrons are sufficient and it is good to undergo electrophilic substitution reaction at the meta position, means third position. Okay, ಅದಕ್ಕೆ third position ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ electrophilic substitution reactions ಅನ್ನೋದು ಆಗುತ್ತೆ. either in the case of aldehyde or ketones, both. Now take one example, nitration. So this is the reason to know why the electrophilic substitution reaction is happening at meta position only in both aldehydes and ketones. Got it? Now take example. Example, nitration. Nitration is the example for electrophilic substitution reaction. Now take aldehyde, that is benzoate, aromatic aldehyde, benzoate, CHO. So this is what benzoate, right? Benzoate. Now nitration means, you know, nitrating mixture that is concentrated nitric acid and sulfuric acid, which is treated with concentrated nitric acid HNO3 in presence of concentrated sulfuric acid. Sulfuric acid, you get your nitration product, that is benzene bond CHO. Third portion is nothing but 1, 2, 3. This is third portion here, nitro group NO2. So observe in the previous reaction, it means in alcohols. In alcohols, that is in phenols, particularly phenols. This is phenol. When we are doing nitration, you get ortho and para nitro products. You get like that. NO2. But in case of aldehydes and ketones, you get only one product, that is meta product. Okay, so this is the nitration of benzoate. Its name is 3-nitro-benzoate. Similarly, take for ketone. In ketone, the example is acetophenone, CH3 double bond O benzene. This is what acetophenone, ketone. So which is treating with concentrated nitric acid HNO3 in presence of concentrated sulfuric acid H2SO4. So this is mixture we call nitric mixture in the ratio of 3:1. Now you get the product that is C double bond O CH3 acetophenone. Third portion is 1, 2, 3. This is third portion, NO2. So elimination of water takes place. Here write H2O, but it is not necessary to write. Write no wrong. H2O. Now what is name? 1, 2, 3. 3-nitro-acetophenone. Its name is what? 3-nitro-acetophenone. Okay, so this is the nitration example for electrophilic substitution reaction.